Let's delve into the interpretation of National Electrical Code Section 110.14c concerning temperature limitations of terminations, specifically within the context of an existing 480-volt system utilizing 500 kcmil THWN or THHN cable fed from an existing 400 amp circuit breaker with 75 degrees Celsius rated terminations. The cable routing is specified as overhead rigid galvanized steel conduit. The core concern is whether the 400 amp circuit breaker adequately protects the 500 kcmil cable, especially considering the initial observation that the breaker's rating seemingly exceeds the cable's ampacity as per table 310.16, 75 degrees Celsius column, under a 40 degrees Celsius ambient temperature. This yields an ampacity of 334 amps, theoretically necessitating a 350 amps breaker for proper protection. The interpretation of Article 110.14c allows consideration of the 90 degrees Celsius ampacity and its associated derating factor to determine the cable's adjusted ampacity. However, the initial derating factor used in the question was incorrect. The correct derating factor for a 40 degrees Celsius ambient temperature when starting from the 90 degrees Celsius column is 0.82, not 0.91. This means that the cable ampacity is calculated as 430 amps, the 90 degrees Celsius ampacity from the table, multiplied by 0.82, resulting in 352 amps. This 352 amps is still higher than the 75 degrees Celsius ampacity of 334 amps. Therefore, the 400 amp circuit breaker, in this scenario, does not adequately protect the 500 kcmil cable according to the provided parameters and code interpretation. Addressing the question regarding exceeding the 75 degrees Celsius temperature rating of the terminations, it is crucial to understand that the termination doesn't necessarily operate precisely at 75 degrees Celsius under normal load. The 75 degrees Celsius rating signifies the maximum temperature the termination can withstand without immediate catastrophic failure. Exceeding this rating doesn't cause instant failure, but it accelerates degradation of the termination materials. This degradation, occurring over time, potentially spanning years or even decades, leads to diminished performance and eventual failure of the termination. In the given scenario, with the 500 kcmil cable, the 400 amp circuit breaker, under overload conditions, will not trip until the cable approaches the higher ampacity of around 380 amps. However, the 75 degrees Celsius rated terminations will begin to degrade well before the cable reaches that temperature. The cumulative effect of this heat-induced degradation weakens the termination's integrity, potentially leading to a premature failure and subsequently disrupting the circuit's operation. In summary, although the cable insulation can withstand higher temperatures, the terminations are the limiting factor. Operating the terminations above their rated temperature will shorten their lifespan and increase the risk of failure, irrespective of the cable's insulation rating. It is essential to adhere to the temperature limitations specified by the terminations rating and ensure that the circuit breaker provides appropriate overcurrent protection based on the lowest temperature rating of any component in the circuit, including the terminations.